Hello, everyone, and welcome. Thank you so much for joining us today for this webinar. My name is Riley, and I assist in coordinating EIT's various webinars we have every month. Our technical topic webinar for today is Enhancing Energy Efficiency via Building Design, which is being presented by one of our civil and structural engineering lecturers here at EIT, Dr. Ana Evangelista. Please note that these webinars are recorded and everyone will be sent the PowerPoint slides and the link to the recording after the session. We also provide a digital certificate of attendance, which we will provide the link for you to fill the form out to receive one at the end of the session. We also have Karma Hello, who is one of our course advisors based in our South African office. We aim for these sessions to be interactive, so please use the chat box if you would like to ask any questions or provide comments. I'd like to hand over to Dr. Ana now, who will be our presenter for this session today. So thanks, Ana. Over to you.
Thank you very much, Riley. First of all, thank you everyone for joining us today. I'm a civil engineer, as you can see in some brief introduction. I'm civil and structural engineer, but I'm also very interested in sustainability in construction. That's why some time ago, I joined the environmental engineering program in Brazil, Federal University of Rio, and now I can just work in both areas, structural engineer and environmental engineer. Now, more and more we need to be able to work in a multidisciplinary team, and sustainability is something that must be in our career nowadays, right? So the main idea today is just to discuss some alternatives in terms of how we can enhance energy efficient in buildings, right, via building design. Just feel free to let me know if you have any questions. You can use the chat box or you can leave to the end of this session, right? I'm happy to answer your questions according to the best of my knowledge. So thank you so much for coming today. Let's start our session. The main idea today is just to have a brief introduction in terms of the green building certifications, why it is important. Nowadays, we have the International Energy Agency, and in terms of energy consumption, we have some impressive data. We have, in terms of commercial and residential buildings, normally we have available this data from IEA. Our sector consumes around 1/3 of the world's energy. And as you know, in buildings, energy normally is used for heating, cooling, ventilation, lighting, water heating, and cooking. So the main idea here is just to analyze some benefits of energy efficient design under different construction alternatives. We know that the poor quality in terms of design can lock in some excessive operational energy use and for many years. So we impact, we result in some environmental impact for many years. So we also need to consider high levels of waste in our industry. It's another topic that we can discuss, but it's all related about the poor embodied energy outcomes. Right? When you select materials as well, we have so different approach just to consider when we looking at how we can mitigate environmental impact. And that's why we'll be discussing energy efficiency. We have a brief introduction in terms of life cycle building phase. And hopefully at the end, you'll be discussing some integration between building information modeling and life cycle assessment. Okay, and at the end, as you know, we have some time for questions and answers. Let's start with the next slide. You'll be looking at, as you know, why we need to think about green building certifications. As engineers, architects, or construction managers, all these environmental certifications, what the aims of all of them. Doesn't matter, Green Building Council, Green Star, we have around the globe different certifications, right? The main idea is just to improve our industry in terms of sustainability, right? How we can have better usage of natural resource, and these in terms of how we can reduce carbon emissions. There are so many aspects in relation to the green building certificates. So in terms of the environment, we can think about alternatives just in terms of conservation of natural resource. We know that our industry consumes a lot of natural resource, construction engineering. Also, in terms of business, benefits, new markets, in terms of how if you can demonstrate to your clients that you can become a sustainable company, right? You can increase your credibility under this area. As you know, you all are aware that we need to have in mind the Sustainable Development Goals, and it's how our sector can contribute. That's why you have so many different possibilities here under the green building certifications. How we can promote cleaner products and process in our industry. It's all about green building certifications. So next one, let's have a look in terms of energy efficiency. I'm not sure if you are aware, but the International Energy Agency, IEA, normally this organization can track energy intensity in our sector, building sector. And as you can see here, in terms of energy intensity is the final energy use per square meter, okay? And over time, we can just observe here into this diagram, into this chart, that there is a trend in terms of the reduction of energy intensity. So it's something that is still, it's happening in a slow pace, but it's something that our industry is changing. Construction sector is changing into this, according to this data available from EIA. Also, in terms of different countries, these organization just tracks the energy efficiency, energy intensity in different countries, such as we have some countries, Africa, in some Asia countries, Latin America, South America, for example, and now we have some movement around the solid biomass usage. So these can contribute to decrease the energy intensity, okay, issues. So majority of the countries normally you have here around 2/3 of the countries nowadays locked some, we need to have some mandatory building energy codes. So 2019, 2/3 of the countries have now these mandatory building energy codes, but we need more of these, right? This is the trend, it's just to increase the number of countries just working with building energy codes. And then we can reduce the amount of energy that we are using in our industry. So into the next one, let's have a look. Another important point that I'd like to cover with you today. Heat and cooling, right? These are some important aspects that you can consider. And about heating, as you can see, here you have this line. This line refers to the Sustainable Development Strategy. What the main purpose? 2030. It seems so far, but it's not so far. The main idea is just to try to reduce the fossil fuel-based equipment, right? If you think about heating. And when you think about cooling, space cooling, just to have a broad idea here, is about, in terms of emissions about 1 gigatons CO2 emissions, right? Nearly 8.5% of total final electricity consumption in 2019. So we need to consider these type of factors, heating and cooling. In terms of cooling, aircon units, now they are becoming more and more efficient, which is a good one. But what we need in terms of the sustainable development strategies, energy efficient standards needs to be implemented, and we still have room to improve it, and aircon energy performance must be much better in 2030. What is important about the International Energy Agency, because we can just have a look, keep an eye on these numbers and have a better idea about in terms of energy consumption in our industry, right? And what can be done to improve it. And it's also, here we have another interesting data to analyze in terms of lighting. We know in terms of design, you have different approach just to improve natural light. We can maximize daylight. We can just use some skylights where appropriate, but let's have a look at the lit sails. Now, according to these data, what we can have, this is a good news I can see here. It's increasing the number of the sales of LED, because in terms of this one, what is happening into the market in different countries, the cost is falling, right? And the sales are growing on track with some. So the marketing of these LED are increasing, and hopefully the main idea, according to the agents, International Energy Agency, according to this organization, these data will be retrieved from their website, 90% of sales in 2030. So all these sometimes we can consider some minimal points that we can contribute will improve our industry in terms of energy consumption, right? Some points that we can improve in our industry. But thinking about buildings, right? Here is just to share with you when you need to analyze environmental impact of buildings. I know that today our main focus is in relation to the energy efficiency, but as you can see, different states, extraction of raw materials, manufacturing, construction sites, operation and maintenance, demolition, all these phase demands lots of energy, right? Even depends on the selection of material, depends on energy construction. All we need to consider the embodied energy when you select materials, if you're looking at the pre-building phase. So today, we will be looking at the operational phase of buildings. That's why you'll be referring to some factors that we need to consider when you are designing a new building, okay? So here we have a brief idea in terms of life cycle building phase, because when you conduct a life cycle assessment of buildings and you are keen to estimate the energy consumption into these different phases, we need to have the best idea in terms of the entire life cycle of buildings. That's why nowadays, we have these very powerful tools. We have different software, building modeling software, and we can also combine this approach with life cycle assessment. When you combine, for example, when you combine these methodologies, life cycle assessment, and you have your model available via build information modeling, we can combine this type of analysis. We can have different parameters. As you have your model, you have your building. Now we know these softwares nowadays our design is unchecked. When you have your buildings, you have all the information in terms of the materials, characteristics, thermal properties, building envelope materials, all the systems combined. And that's why we can have this type of analysis. For example, if you integrate some analysis from Green Building Studio with some software that we can incorporate plugin into in this case, as an example of Revit, we can use Revit and Green Building Studio, and attached to this, we can work with life cycle assessments. We have different software available in the market just to assess, just to conduct life cycle assessment, but here is more to share with you type of analysis that you can conduct, and you can just play with different parameters. And then you can compare life cycle electricity, energy, life cycle of electricity if you use, and when you use electricity, or when you can use fuel. And in this case, it's just to share with you, when you have different parameters, here's just a comparison in terms of what sort of systems you can use, different materials, different openings in terms of windows and doors, ratios. We can conduct this type of analysis. And here is much better to illustrate what I'm talking about now. For example, combining BIM and LCA. It's a very simple example I can share here with you, but what sort of parameters we can use to analyze, for example, in this case, operating energy efficiency, just thinking about cooling loads. In this case, what we have here, we can compare two different approaches. We compare, in this example, case A and case B. I will highlight this one just for you, case A and case B, and what sort of components we are looking at. Different components, type of structure, walls, materials, different materials, finishing. For example, here we just using ceramics, and case B, we can use a different material. But when the main idea here today is just to call your attention that we have these powerful tools in our hands just to improve our decision. We are, at some point, we are responsible to make some important decisions into the design. And how we can do this nowadays? We have simulations, right? And here is an example how simulation can help us just to decide the most suitable approach, most suitable material in terms of the building that we have in our hands to design. And in this case, here is just an example, right? In terms of the office buildings, an example from Brazil. And here is just when you have these results, we can just analyze in terms of during the year for different approach, case A and case B. Previously, you could see the difference, the main difference when we are conducting these simulations. We can play with materials, we can play with the structure, the structural elements, just to analyze. And here, at the end of the day, what simple outcome that you can compare. If you look at case A and case B, the main idea here, between January and December, okay? We have January, February, March, April, and December. We have these months when the stream contribution in terms of walls for case A. Here you can see materials, walls. Case A, you can see the contribution of walls pretty much here at the very beginning of the year, and then in December. And in case B, we have the windows, right? So for now, what I really want to share with you is these possibilities. I'm not here just to go into details of this analysis, but in summary, we can use the powerful tools nowadays, such as Revit or other types of software and life cycle assessments analysis, just to give us the best idea in terms of how we can select materials, how we can determine the suitable openings in terms of in terms of windows and doors. It depends on different types of roofs. So there are so many different parameters that we can work with just to analyze using these powerful tools. That's why this example is just to briefly share with you how we can estimate the operating energy efficiency and cooling loads. Okay. When you talk about energy efficient in design building, we need to think about the heat loss, heat energy loss, how we can estimate this. It is very important energy loss here. The heat energy loss, what we need to think is exactly the point that we have here. I will highlight with just for you to share. We need to consider all the thermal exchange that can occur in the building, right? And it happens via, I said before, depends on the walls, the materials, depends on floors, roofs, windows of this building. And normally what we need the total, we have the heat energy loss, the total energy loss, and how we can calculate this. We need to consider the fabric energy loss, heat loss, and also we need to consider the ventilation heat loss. Here it is again, is just to share with you that when you assess the heat energy loss in buildings, this will help you to design some passive and active systems. The main idea at the end of the day, at the end of this analysis, is just to provide some efficient, sufficient thermal building conditions. Why we need this? Because then we can minimize the consumption of natural resource. This is the main point. Okay, so normally it occurs through the fabric heat loss and ventilation heat loss. And we're gonna have a look at these two parameters in a sense, right? Usually, it's also important to highlight with you. Normally, the heat energy loss is normally the most important, one of the important factors is the building envelope, because exactly at this point, we have the heat exchange, where have the heat exchange occurs from the warmer indoor environment to the cooler outer environment. So these are some parameters normally we need to have in mind at the moment that you are designing a new building. That's why at the very beginning, I told you that more and more is important to work in a multidisciplinary team, engineers, not only civil, but sometimes mechanical engineers, architects, and construction managers. We can contribute, right, in different aspects. And this diagram is also important. I'm willing to share with you some possibilities how we can conduct this type of analysis, how we can estimate energy heat loss. We have parameters, important parameters. I will highlight here. I try to different color just to make it more easy for you to visualize. So parameters that we need to consider: building geometry, building technologies, building envelope, and transportation, right? So for each of them, we have, for example, building geometry, the number of levels, Okay, we have, in terms of building technology, you have the U value. It's a very important parameter that we need to work here. So we also have, in terms of U value, just to highlight, is our thermal transmittance. It's gonna impact the fabric heat loss, and it's also important component of a building envelope in different areas, right? And in terms of the air temperatures, there are parameters that we need. When you look carefully into these different parameters, for example, building envelope, components of envelope, what sort of components we can see here? We have the walls, roof, floor, windows, door, all these will influence. All these points, as we could, I'm trying to highlight here, it will impact both, right? Will impact here the fabric heat loss and ventilation heat loss. And at the end of the day, we can estimate the total heat energy loss. Also, we can indicate the building components affecting the heat loss. Okay, we have some mathematical equations. We have some formulations to conduct these, just to analyze all these factors and how we can calculate the fabric heat loss and ventilation heat loss. So here is just to give a broad idea in terms of the framework that you can use to estimate energy heat loss. You know, this is a very important aspect if you're thinking about energy efficiency. Heat loss is, as the name says, sometimes you consume more energy than you need. So we have some performance parameters, you have design factors, and then that's why we normally work with some simulations just to be able to validate all these formulations and just to decide. Just sometimes you just need to compare different designs, different, or in terms of the windows, the ratios, and just to identify exactly the points that we can improve in our design, just to reduce, just to mitigate the energy loss. And here is just to illustrate, just to share with you that we have here the fabric heat loss, and these depends on factors that we need to consider. As said before, we need to consider the transmittance U value. For different materials, you're gonna have a different response. What I can say today, we can work with the software, like building information modeling software. And for example, these green building students, this software that you can estimate energy, because we can work as we can just imagine that we are walking into the lab and we can play with different factors and parameters. And that's why later on we'll discuss the design of experiments, because it's how we can have a better analysis when you can work with a range in different factors that we'll be looking at. Okay, so we need to calculate in our design, in our analysis, we need to calculate the fabric heat loss of construction components. Also depends on the area of each building component and the temperature, the difference of air between inside and outside environment. So some illustration here to share with you. And in addition to this one, we also need to work out the ventilation heat loss. We know ventilation is super important in your design, because this is the process when you have the replacing air in any space to provide, the main goal is to provide high quality indoor air quality, and it happens through the building envelope, as you can see here, these diagrams. Ventilation, that's why we need to consider all these openings, doors and windows, right? Also, we need to observe materials selected when you are selecting materials, determine the materials that will be applied into the floors, also the design of roof and materials, and materials, wall materials as well. So we can, these are the main important points to consider when you need to estimate the ventilation in building, and in this case, ventilation heat loss in buildings. And in terms of simulation, for sure, you can have complex projects, but for today, I selected this very, very simple example. As you can see here, we have in this case study, we have this simple project, this single house, just one level. But the main idea here today is just to share with you, when you conduct this type of analysis, we need to consider the climate classification, and also we need to consider the air temperature of the cooling period, right? And for this simulation, what we decided just to look at some specific climates: tropical climates, dry climates, and moist subtropical mid-latitude climates. So we have this table available in the literature. This is provided by this author, Köppen classification. We have these different climates, and for example, these three types: type A, type B, and type C. We decided to work with this one because this covers more than 6% of global surface area. It's just a trial, right? But it's a very good example in terms of how we can conduct the heat loss analysis. And that is a very interesting outcome that I'd like to share with you. For example, in terms of, as this diagram just shows us, right? Very interesting outcome. As you can see here, I will highlight, I just need to collect this pointer. So in terms of fabric heat loss, we consider different materials, right, into this building, into this envelope. And let's start with the fabric heat loss. Depends on the climate. As you can see, what you can observe. We have tropical, we have dry climate, and the moist subtropical. And here we have the transmittance value. And it's super clear now that in this case, even with different aspects considered in terms of floors, walls, roof, and the openings like windows and doors, it's a significant influence. Exactly the type of climate where your building is located, right? So as you can see, the moist subtropical, if you compare with the other one, the difference is significant, right? Much more than the other parameters that we consider in terms of floors, like different materials, or the openings, the other parameters considered into this analysis. Okay, and same happened when we decided to estimate the ventilation heat loss at various climates. As you can see here, same situation for both. These results, we can have it's impressive how we can at the moment that you determine the climate, you can influence the total heat loss in your design. Are you answered the questions? Okay, from at the very end of this session. I know there's some questions popping up at the chat box. Are you answer as soon as possible? Okay. So these are some points that you can consider in our design, some important aspects. And also, there are another point that I'd like to share based on this simulation is during the simulation is possible, as you can see here, when we discussed it previously, the maximum heat loss and the minimum heat loss. You can see the difference in terms of if you compare tropical climates with dry and more subtropical climates. And here is another important point when you just analyze the fabric heat loss. We have here this very important point. We have the openings, the main contribution of openings. In this case, if you compare with the other components. So at this point, you can see there are so many different parameters that you can use. And now more and more we need to take advantage of these important tools available via build information modeling, life cycle assessment, and also software like Green Building Studio that you can calculate the energy loss, the heat loss. And talking about build information modeling, this is the other point that I'd like to share with you today. When I know that in different countries, now the starting point. Okay, I will share, I can see some points. I will share the software later on, at least the name of the software. So talking about build information modeling, you all know how powerful it is because, as I said before, now we are dealing with an object. Our building now is an object, so we can have all the information that we need in terms of the cost, in terms of materials, and that's why when we start with working with BIM, we start becoming more familiar with this 3D modeling, right? We can create, we can visualize our building, but it's not only about this. As much as we familiarize with all the others BIM dimensions, we can also incorporate, we can use more than one software just to take advantage of in the real time, just to visualize our construction schedule, our construction cost, the operation and maintenance, and sustainability. This is the point that I'd like to highlight today. So if you look at the entire life cycle phases, you can start working since the planning and design phase, but also in terms of the operational and maintenance phase. And when you think about sustainability in the yellow here, as you can imagine, decisions that we need to make in terms of design, in terms of material selection, it will impact a lot the sustainability of in our construction. Okay, the sustainable aspects of our construction, based on the design, based on the selection of materials, you have a significant influence, right? Pretty much here, planning design phase and construction design phase. Other points that I'd like to share with you today. We have also how to also related to build information modeling. We have the energy unit here, how in relation to gross building area. So we can work out all the loads, the heating, the cooling, lighting, all the equipment that we need to use, pump, in relation to the gross building area, right? So we can articulate all these demands, and it can on these according to the in terms of the energy consumed in buildings, as we could just discuss at the very beginning, it will be depend on the heating load, cooling, the lighting. If you're working with natural light, it depends on the lamps that you normally select. Also the equipment in relation to the gross building area. So this is the important point that we need to consider as well, that I'd like to call your attention. And the other point, how we can combine build information modeling and how we can take advantage of build information modeling and performance of our projects. Just an idea in terms of we need to start with the design requirements, and that's why I told you we need to consider working a multidisciplinary team. We can have energy analysis, architecture analysis, and thermal comfort analysis as well. So the majority of the energy consumption, as you could see before, it's caused by, we know this, but we need to find alternatives, how to improve our design, knowing that heating, cooling, idling, these are the loads that are gonna influence the energy performance of your building. And you have to think for long term, right? So normally it's gonna have an holistic approach in terms of energy consumption and emission. So that's why we also need to work together and with architecture analysis just to predict the post-occupancy performance in buildings is another important parameter that we need to have in mind. And the comfort analysis, we need just to raise all the issues in terms of sustainable. People must be satisfied with your living in a building that you have the you have the thermal comfort just to make your in terms of satisfaction of users into this building, right? What else you have here? We also have, just to share with you, we have designed some decision support analysis. How we can do this, as we just discussed at the very beginning. When our input, when you need to finalize and have a final decision in terms of the design parameters that you'll be working with. Initial step, we have our model, 2 or 3D model of this building. This way we can just thinking about the consumption of energy during the operation phase of this building. We need to look at the building properties. What sort of building properties? We need to think about the space and area and basic appliance, type of energy use, if you're going to work with renewable energy or not, and building components, right? Building components and materials. So that's why we have these, just to summarize how we can conduct this analysis. We can, as I said before, you can start with our 2D, 3D building modeling. Then we need to combine the building design envelope according to the climate. As you could see before, we need to determine the climate in terms of the climate classification, then the building function of building usage, and the building components, exterior walls, roofs, all these details, all these parameters we can work with, right? And these are based on these analysis, based on all these parameters, we can just determine the efficiency of our building, the energy consumption of our building. This is another perspective. The main idea here is how we can use the tools available just to improve energy performance in our industry, construction projects. And our starting point, we have our construction projects. As said before, first step, we need to combine building modeling and the climate data. And also into the second step, what we can what can be done? I said before, we have so many different parameters to analyze. For example, window to wall ratio, building components, all these factors, we can work with a range of these values, these parameters, right? And then in this case, we can conduct experimental design. We can use a software like Minitab just uh, to have a better idea in terms of what sort of parameters, what the range, the decided range that we need to investigate of these parameters. And then you have all, in terms of software, still something to highlight here. It depends on which one you are more familiar with, you are comfortable to work with. And here is just an example, okay? We can, for these case studies that we discussed today, we worked with Autodesk Green Build Studio regarding its interface with Revit. And we have the third step, we can have our final decision. Okay. And here, just how we can just validate all these decision support analysis, how we can validate this. We can conduct some simulation. As you can see here, we can have a variation. That's why design of experiments is very important, because we can just play with different cities, different climate groups, and in terms of classifications, different classifications. For example, in Dubai, we have hot desert climate. In Rio de Janeiro, we have tropical climates and tropical savanna climate. And in this case, we just conduct a simple analysis. Here you have the 2D with a single family house. But this is important just to validate the framework. And is to share, the main point today is to share with you. For example, in terms of walls, we can work with different types of materials and different thickness of this wall, right? In terms of roof, we can have different types of roofs as well. And very, very important factor to consider, we could analyze into this simulation, window wall ratio, right? That's why we can have these different factors. And at the end, what we need to analyze the energy use intensity, right? This is just, we don't need to analyze this diagram. It's not the main purpose. The main purpose I will show in a sequence. That's why we conduct the design of experiment, because here, as you can see, all the factors that we could work with in terms of simulations. And for this example, for sure you can increase, you can work with more parameters than we use it here. But I said before, this is just a case study, just to validate the framework. We decided to work with the single family. And these are the parameters that we just decided to work with. Window walls ratio. But as you can see, in terms of this one, we decided to analyze 15%, 30%, 40%, 50%, and 65%. And just going back for a while. And the main idea is the focus is the energy use intensity. And as you can see here, lots of outcomes that we can obtain from this analysis. We can remember that we are comparing different cities in different regions, different countries. And then with this, considering this type of analysis, you can have this compare what happened in different design. You can have the design aspect here, but also attach it to the location, to the climate where the building is allocated. And here, Again, it's just to illustrate the energy use intensity is something that this is the important point that we need to consider. And for each the window to wall ratio, as you can see here, we just decided to analyze the lowest and the highest energy use intensity considering different locations. So this case study is more to share with you the numerous alternatives and options that we have out nowadays. If we start working with this combination of life cycle assessment, energy, we need to consider the energy efficient and heat loss. And just to conclude, I just want to share with you some insights in terms of what can be done in terms of analysis just to enhance energy efficiency in buildings. We have, for example, climate classification is something that we need to consider important parameters. For example, 33 to 50% of energy, same building, but in the continental climates and polar climate compared with other classifications, right? And also this case, one of the case studies just showed that the subtype climate classification, the impact is not significant. Minor role influence energy consumption in buildings. But here, why I'm talking about insights is just to open our mind. I'm not saying that for this application, for this simulation, these are some insights that we could obtain. Strong relations between openings. It depends on your perception. Sometimes architect, it can be a bit of obvious, openings and energy use intensity, but you also analyze different climates and other parameters in terms of, for example, different windows to wall ratios, and this one of points that you could highlight here. And more, it's growing. Building information modeling is a very important tool to improve energy efficiency in buildings. This is the main purpose of this webinar, is just to open our mind and what sort of parameters we can play with, what sort of software we can work, and how we can calculate the heat energy loss, depends on your design, right? And the other points that I'd like to share, of course, as civil engineers or architects, we can just have this approach in terms of passive design, but also renewable energy is another possibility. When you look in different resources in the literature, there are so many options in terms of passive design or solutions that all together can improve the energy efficiency in our buildings, and even more, you can work with renewable energy. More and more, you have solar energy in different countries. We have this possibility here in Australia is huge, I can tell you. And for example, ceilings and roof space is important to consider as well. 25 to 35% winter heat loss. That's why it must be very well insulation, right? Is another important. And all this is just to summarize that we have the Sustainable Development Goals, and we know our industry, sadly, construction sector is well known as the industry of 40s. You know why? 40% energy consumption, 40% usage of natural resource, and 40% waste disposal. So it's time for all of us to work collaboratively with architects, mechanical engineers, civil engineers, just to try to change a bit how our industry is well known nowadays. So some ideas that I'd like to share with you. So it's over to you, Riley. I know that so many questions in the chat box. If it's not possible to answer today, I'm happy, Riley, you can forward some emails and I can reply the questions properly. Okay? It's a huge
Thanks,
topic.
thanks, Anna. We'll have a quick Q&A and just questions. But otherwise, if we don't get to your question, we'll endeavour to get back to you on that. Thanks so much, Dr. Anna, for such informative presentation and sharing some in this area. I'm sure everyone interesting and insightful. So, and I'd like to let everyone know we're finalising our next technical topic webinar of May, which is going to be focused in manufacturing, being presented one of our engineering lecturers here at EIT. Link to this next technical topic webinar, the PDF slides and the recording of this webinar. Please expect to receive this webinar slide recording in the next 2 business days. To receive your digital certificate now, please fill out the form via the link provided in the chat box. The link is also shown on a certificate of attendances will be sent business days. On to our Q&A section. I think Anna wins from Jeffrey.
Yes. Yeah, Jeffrey. He's asking about how we can determine the gap. We need to analyze it, Jeffrey, the air gap, and we have to work with the. Remember that we covered the equation just to work with the fabric heat loss. We need to consider all these materials, and then we can work with the thermal transmittance. Depends on the type of material. You can calculate the fabric heat loss using the thermal transmittance. Depends on the materials.
Thanks, Anna. We also had one, Kushal, I think. Did you brief software? Is wanting to determine the energy efficient design and the simulation heat.
Yes, in this simulation we have, it's available in the literature, other softwares, but in this case we worked with the Green Building Studio. It's a plugin. If you work with Revit, we can work with this software. I think Kushal just asked this question. And if any other question, feel free to send me an email, Riley. I think they will get in contact with you and you can forward their emails.
Yeah. All of our content, including our website, our email address, if you would like to get in contact with me, have any questions or comments about the webinar, yeah, feel free to tell us down. But otherwise, has any more questions, please feel free to in the chat box. But otherwise, running today, and we would like time for our next technical topic webinar. So, thanks, Anna.
Thank you very much, and feel free to get in touch if you have any question. Thank you all for coming. Thank you, Riley, for having me here today. Thank you.
No, for being active. And thanks, everyone.